Chapter 11, we're looking at analytic geometry in 3 dimensions. So we're going to plot points in the 3-dimensional coordinate system. We're going to find the distance between points in space and find midpoints of line segments joining points in space. And we'll also write equations of spheres in standard form and sketch traces of surfaces in space. So first let's take a look at the 3-dimensional coordinate system so we get an idea of what it looks like. So we have our x-axis and our y-axis, and we have normally graphed that on the Cartesian plane. That's 2 dimensions. So what we're going to add to the third dimension is we're going to use z here. So notice we have the xz plane, the yz plane, and also the xy plane here. And so now we're going to take a look at the octant. So we have to look at our positive x-axis, positive y-axis, positive z-axis. So notice this positive x is here, positive y is here, and positive z is going up. And so the first octant is here in this space here. Then it rotates counterclockwise. So then the octant 2 is back here. So it's a negative x, still a positive y, and a positive z. And then here, this is our negative x, negative y, and positive z. And then back over here is our octant 4. Then octant 5, from the top, you just move down, and then it rotates in the same direction. So, in the homework, you have to identify what octant is an ordered triple. So let's go ahead and plot some points in space. Plot each point. We have 2, -3, 3, -2, 6, and 2, 1, 4, and 0, 2, 2, and -3. So the first point here represents x, this is y, and this is z. So again, knowing where we are, so notice here, this is our positive x is here, positive y, then positive z, and then negative z, negative x, and negative y. So we're going to plot 2, -3, and 3. So 2 on the positive x goes up 2 here. Then we go -3 for our y value. So we're going 1, 1, 2, 3 here. Then we go positive 3 up, so that's 1, 2, 3. So this point here is 2, -3, 3. Let's do the next one, -2, 6, and 2. So that's a negative x, so that's 2, positive 6, 1, 2, 3, 4, 5, 6 here. And then up positive 2, so 1, 2. So here is -2, 6, and 2. Let's do 1, 4, and 0. So positive 1, positive 4, and then 0 is here. So that is 1, 4, 0. And then our last point is positive 2, then positive 2, and then down 3. Which is down here. So this is 2, 2, -3. Okay, so try this on your own. Plot each point in space here. All right, so you should have had these points here if you tried it out. So now let's look at the distance formula in space. So the distance between the points x1, y1, z1, and x2, y2, z2 is given by the distance formula in space. So notice it's d equals the square root of x2 minus x1 squared plus y2 minus y1 squared plus z2 minus z1 squared. So really we're just using the distance formula for all of our points, x, y, and z. So the x's are together, the y's are together, and the z's are together. So example 2, let's find the distance between the 2 points in space using this distance formula. And so, you could, if you needed to, label each point just to help you out. And then so let's find the distance. So the distance equals the square root of 2 minus 1 squared plus 4 minus 0 squared plus -3 minus 2 squared. So if our distance equals 1 squared plus 4 squared plus a -5 squared, so this is square root of 1 plus 16 plus 25, which is the square root of 42. So try this next example. So we tried it out. You should have gotten the distance is square root of 35. Now let's take a look at the midpoint formula in space. So notice it's very similar to the midpoint formula in 2 dimensions. So now we're just doing x1 plus x2 over 2, y1 plus y2 over 2, and z1 plus z2 over 2. So let's try that in this example. Find the midpoint of the line segment joining 5, -2, 3, and 0, 4, and 4. And again, if you need to, you can always label this just to help you out, but not necessary. So we have our 5 plus 0 divided by 2, then our y's, which is -2 plus 4 divided by 2, then we have 3 plus 4 divided by 2. So this is 5 halves. Then we get -2 plus 4 is 2 over 2, and 3 plus 4 is 7 over 2. So to simplify, it's 5 halves, 1, and 7 halves is the midpoint of the line segment. So go ahead and try this next example. So trying this out, you should have gotten 5, -3, and 1. Now the equation of a sphere is with the center h, k, and j, and radius r is given by this formula here. So x minus h squared plus y minus k squared plus z minus j squared equals r squared. So very, very similar to our circle here. If the center lies at the origin, then the equation is x squared plus y squared plus z squared equals r squared. And, I hope you see that, because if this is all 0, then that all goes away. We're going to find the standard equation of the sphere with center 2, 4, 3, and radius 3. And so we know that this is going to be, the center is h, k, and j. So h, k, and j. And our radius is 3, so that's r. So let's just plug it in. X minus 2 squared plus y minus 4 squared plus z minus 3 squared equals 3 squared. And of course you can simplify that. So it's x minus 2 squared plus y minus 4 squared plus z minus 3 squared equals 9. And it does ask, as the sphere intersects in the xy plane. So if you were to graph this 2, 4, and 3, the center at 2, 4, and 3, and radius 3, you would see that yes, it is in the xy plane. You could do that if you wanted to over in this extra plane here. Now we're going to try find the standard equation of the sphere with center 1, 3, and 2, and radius 4. All right, if you tried this out, you should have gotten x minus 1 squared plus y minus 3 squared plus z minus 2 squared equals 16.